video, we'll look more carefully at scale factors and how they help us reason through similarity problems. Mathematically, we say two shapes or objects in a plane or a space are similar if every point on one object corresponds to the point on another object, and there is a positive number, k, such that the distance between any 2 points on the second object is k times as long as the distance between the corresponding points in the first object. That's a lot. But the important thing is this scale factor, the number k. This is how much we are increasing or decreasing the image. So a scale factor is the number that tells us how much bigger or smaller the new figure is compared to the original. Because of the consistent scale factor, a collection of distances within the second object, like length, width, and height, are in the same ratio as the corresponding distances within the first object. So if one length is multiplied by 3, all corresponding lengths must be multiplied by 3. That's what keeps the shape the same. Let's look at an example. Suppose we have a toy model car box that might say the toy is a 24:1 scale model of an actual car. That means the toy car and the actual car are similar. The scale factor from the toy car to the actual car is 24. Equivalently, the scale factor from the actual car to the toy car is 1/24. So the length, width, and height of the actual car are each 24 times the corresponding length, width, and height of the toy car. Now, let's reason through some examples. Suppose we have a sculpture, and we have an artist that wants to create a scale model of the sculpture. The scale model is 10 inches wide by 20 inches tall. The actual sculpture, when it is made, will be 60 inches wide. So how tall will the actual sculpture be? First, we need to find our scale factor. How do I get from 10 to 60? I multiply by 6. So 6 is my scale factor. We need to apply that to the height as well. 20 times 6 is 120. So the actual sculpture will be 120 inches tall. Let's look at another one. Let's suppose we have a postcard with an attractive picture on it, and we want to scale up the picture to draw it on a piece of paper that we can cut from a roll. So we have a much bigger one here. The roll of paper is 20 inches wide, and we can cut the paper to virtually any length. The postcard picture is 4 inches wide by 6 inches long. We want to assume that the 4-inch side will become the 20-inch long side. So how long do we need to cut it? First, we need to find our scale factor. 4 times what is 20? And that answer is 5. So 5 is our scale factor. We multiply every length by that. 6 times 5 is 30. So this would be 30 inches long. We should cut the paper to 30 inches long. This is another great example of similarity. The shape of the picture stays the same because every length is multiplied by the same factor. As future teachers, this is a strong place to ask students, what is staying the same? What is changing? How do you know the scale factor is consistent? Those questions help students build understanding instead of only plugging in a formula. You have now worked through congruence, triangle congruence criteria, similarity, scale factors, and reasoning through these scaled situations. That's a lot of important geometry thinking. Take your time with it. These ideas become much easier when you can connect them to pictures, paper models, and real-life scaling situations. and you are absolutely capable of making sense of all of this.